In this video, we're going to discuss the difference between ionic, covalent, and metallic bonding. In ionic bonding, electrons are transferred from one element to another, and typically ionic bonds contain ions. In a covalent bond, electrons are shared, but let's go over ionic bonding first. Let's consider the reaction between an atom of sodium and an atom of chlorine. Sodium as an atom has one valence electron. If you look where it is in the periodic table, it's in the first column. It's in group 1A. And elements in that group all contain one valence electron. A valence electron is simply the electrons in the last or outermost energy level. Chlorine, which is a halogen, contains 7 valence electrons. It's in group 7A of the periodic table, and the halogens are usually very reactive nonmetals. The alkali metals where sodium is found are very reactive metals. In bonds, metals usually give away electrons, and so they form positively charged ions. Nonmetals like to receive electrons, and so they form negatively charged anions. So in this bond, sodium is going to give chlorine one of its valence electrons. So as sodium loses that one valence electron, it's going to acquire a positive charge. And as chlorine gains that electron, it's going to acquire a negative charge. You have two like charges next to each other. What's going to happen? Like charges are most likely to repel. They're going to feel a force that repels them or pushes them away from each other. But what's going to happen if you have a positive charge and a negative charge? These two are attracted to each other. They feel a force of attraction that pulls them together. And so that's what's happening between the sodium ion and the chlorine ion. The sodium ion, which has a net positive charge, is attracted to the chloride ion, which now has a negative charge. It binds them together, and so that creates the ionic bond. So keep this in mind. Within ionic bonds, you have a transfer of electrons, and the bonds that hold them together are as a result of the forces between the opposite charges. Now let's move on to covalent bonding. Let's look at hydrogen, for example. A hydrogen atom has one valence electron, and it's in the first row of the periodic table. Elements in the first row, they have a total of 2 electrons in their outer energy level. The second row elements, they want to have 8 electrons. So elements like oxygen, fluorine, they want to satisfy their octet, they want to have 8 electrons. But hydrogen and helium, they only can have 2 electrons in their first shell. So each of these hydrogens, they need one more electron to fill that first shell with a total of 2 electrons. And both of these elements are the same, so what they're going to do is they're going to share their electrons. This sharing of electrons will form a bond between the two hydrogens, called a covalent bond. So when you see a bond like this, it represents the sharing of 2 electrons. Anytime there's a sharing of electrons, it's a covalent bond. So there's 2 types of covalent bonds: polar covalent bonds and non-polar covalent bonds. The bond between the 2 hydrogen atoms is considered to be non-polar covalent bond. The reason why it's non-polar is because the electrons are shared equally between these 2 hydrogen atoms. Now, if you look back at the bond between the hydrogen and fluorine, the elements are different. Fluorine is much more electronegative than hydrogen because fluorine is going to pull the electrons towards itself. Now, granted, the electrons are still being shared, but they're going to be shared unequally. Whenever you have an unequal sharing of electrons, it's going to be polar covalent, as opposed to a non-polar covalent bond where the electrons are shared equally. So because fluorine is more electronegative, it pulls the electrons towards itself. Fluorine is going to acquire a partial negative charge, and hydrogen is going to be partially positive. Whenever you have an object where one side is negative and the other side is positive, it's going to be called a dipole. And basically when an object is polarized, this means that when you're polar, you have an unequal distribution of charge. One side is positive, one side is negative, so the electrons, they're not distributed evenly in that molecule. The electrons spend more time closer to fluorine because it's more electronegative. Electronegativity is the ability of an atom to attract an electron towards itself, and fluorine does a good job at doing that. Now that you know polar covalent bonds and nonpolar covalent bonds, it's time to move on to metallic bonding. So metallic bonding is one of the easier bonds to understand because it only occurs between metals. In this type of bonding, the outer electrons of the metal atoms are not bound to any specific atom and can move freely throughout the entire structure. This creates a quote-unquote sea of electrons that is shared by all the atoms in the metal. Now that you've learned the 3 types of chemical bonds, it's time to go over some practice questions. Here are a few examples of different types of bonds. Okay, so first we have NaCl, aka salt, and this bond will be ionic because it consists of a metal and a nonmetal. In this equation, sodium is the metal and chlorine is the nonmetal. In this bond, sodium, as an ion, has a +1 charge, meaning it's going to give away 1 electron to chlorine. Chlorine, as it receives that 1 valence electron, it's going to acquire a -1 charge. These 2 ions have opposite charges, therefore they have a force of attraction that keeps them together. Similar to NaCl, magnesium oxide, magnesium is the metal, it's on the right side of the table, and oxygen is a nonmetal on the left side of the table, making it ionic. In this bond, magnesium has a +2 charge, meaning its ion loses 2 electrons to oxygen, which gains a -2 charge. These ions have opposite charges, therefore, as I said before, they're pulled together, and the 2's cancel out to form magnesium oxide, which we'll go over in another video. Now onto water, H2O. It consists of 2 nonmetals, therefore it's going to be covalent. In order to determine whether it's polar or nonpolar, you have to subtract the electronegativities of hydrogen and oxygen. If the electronegativity difference is equal to or greater than 0.5, then the bond is considered to be polar covalent. If it's 0.4 or less, it's going to be nonpolar covalent. So oxygen has an electronegativity of 3.5 and hydrogen has an electronegativity of 2.1. When you subtract it, you get 1.4. This number indicates that the bond is polar. As you can see here, if you cross over the charges, you get H2O. That will be discussed in another video. Lastly, onto sodium, we have a bond between 2 sodiums, and this is going to be a metallic bond since there is 2 metals. Remember, when there's 2 metals or more, it's always going to have a sea of electrons, no transfer or sharing of electrons. Now let's test your ability to determine whether a bond is polar or nonpolar. Here we have a few examples of covalent bonds, and I'll give you a few seconds to solve them. Okay, so first we have an oxygen bonded to hydrogen, both being nonmetals, and first we have to determine their electronegativities. So oxygen has an electronegativity of 3.5 and hydrogen of 2.1. When subtracting these, you get 1.4, and as we said before, that determines if it's polar or nonpolar. A number higher than 0.5 will be polar, therefore this bond is polar covalent. Next, we have a bond of hydrogen and chlorine. So we'll do the same thing. We'll subtract chlorine's electronegativity from hydrogen's, or the other way around, depending on which number is larger. So chlorine having an electronegativity of 3.16 and subtracting hydrogen's electronegativity being 2.1, and the number we get is 1.06 or 1. So this determines that it is polar covalent again because it's larger than 0.5. Now we have two fluorines. So as we said before, when you have two of the same element, it's going to be always nonpolar because electronegativities are the same and you end up with a difference of 0. This 0 is below 0.4, therefore it's going to be nonpolar covalent. But basically when the elements are the same, it's nonpolar. It's easy as that. Lastly, we have a carbon attached to a hydrogen. So we do the same thing, we subtract both electronegativities. Carbon with an electronegativity of 2.6 subtracted by hydrogen's 2.1 will equal 0.5. Therefore, we can come to the conclusion that this bond is polar covalent. The electrons are unequally shared within the bond because carbon is more electronegative.